Hi guys, so we're going to continue by making a calibration curve, and the calibration curve is going to be completed by or created by using a calorimeter that we have here. This is the device that's going to measure the amount of light that's being absorbed by our solutions. So I'm going to move the camera so you guys can see it a little bit better. This is where we're going to be doing our work. The first thing we want to do is we want to make sure that our calorimeter is calibrated. So I'm going to start by taking my cuvette that stores the solution. I'm going to just add distilled water to it. I'm going to place it inside the calorimeter. You can see it a little bit better. And I'm going to press the button calibrate after I am ensuring that it is on 635 nanometers of red light. So red light is going to be what we're absorbing with our blue solutions. So I press calibrate. I wait for the red button to stop blinking, and then I should have a reading of 0. And so here you can see our graph that shows absorbance versus concentration, and the very first value that was measured is a 0 down here, absorbance of 0 for our distilled water. Now we take the distilled water out of the cuvette and we add our first solution, which is going to be my stock solution, 0.4 molar solution. This has not been diluted. It's just the stock solution. And we're going to measure the absorbance. We're going to wipe off any fingerprints or drops that might have happened by handling the cuvette. Place it into the calorimeter, and we'll get our new reading. Like you can see here, we have our first reading, 0.4 concentration molarity with an absorbance of 0.79. We're not measuring transmission here. We're not going to be graphing transmission. We're just measuring absorbance. So 0.79. And here's our data point to start with. This is our first data point for our calibration curve. Okay, so we're going to remove the 0.4 molar from the calorimeter. Add it back to my test tube, and then I need to make sure that I'm rinsing everything well. So I'm going to take some distilled water and I'm going to rinse my cuvette and my pipette before I get my next solution. My next solution will be the very first dilution. This was made with 8 milliliters of stock solution and 2 milliliters of distilled water. And when I use M1V1, M2V2, that gives me a calculated value of 0.32. So this one is 0.4. Let me get that a little higher for you. This one is 0.4. This one is 0.32. So we're going to measure our absorbance for our first dilution of 0.32 molarity. Okay, so we're getting our first measurement for our 0.32 molarity. So at 0.32 molarity, we have a value absorbance of 0.642. So it's less concentrated, so it's absorbing less light. We're going to keep that data point and place it right here on the data chart. So I'm going to make one more, and then I'm going to do the rest of them without video. Okay, so we're going to remove our 0.32 molar solution from the calorimeter. We're going to rinse with distilled water. And we're going to get our next solution, which is going to be 0.24 molar solution. This one was made by taking 6 milliliters of our stock solution and adding 4 milliliters of water. This is 0.24 molar solution. Place it in our calorimeter and get our next reading. Okay, so our next reading, you can see for 0.24 molar solution, we have a reading of 0.495 absorbance. So we are going down in concentration, and we're also going down in absorbance. We're going to keep that data point, and I'm going to continue to make this graph using these following solutions, these final solutions. So we should have 5 data points when we're finished. Okay, so you can see we have all 5 of our solutions that we created from our stock solution. All these dilutions are created here, and they're plotted on the on the graph of absorbance versus concentration. Now I'm going to add a best fit line, a linear line, and what I'm looking for is the slope of the line. So I'm looking for the y is equal to mx plus b calculation. And I can see that right here. I've got the y is equal to mx plus b. M is 0.92. We have our b of 0.0302. We have an r value of 0.9955, which is quite good. And what we can do is we can plug in values for our y-axis when we get an unknown substance into our equation of a line and solve for our concentration, which would be x. So my next video, I'm going to go ahead and get the absorbance of an unknown solution. Okay, so here I have made up a concentration of a solution that's unknown, and your task would be to try to determine what is the concentration of this solution. And you're going to use the calibration curve and the equation of the line to do so. So the first thing we need is we need to know what is the absorbance of this unknown solution. So I've already calibrated the calorimeter. So we're just going to go ahead and get the absorbance of our unknown solution. Wiping off fingerprints and bubbles is really important. The drops is very important, so we don't change our data by having an increased absorbance. Now we're going to go ahead and look at the absorbance of this unknown solution. Down here at the bottom, the absorbance of our unknown solution is measuring at 0.405. 0.405, so that's going to be our y value. We'll plug that into this equation in line y, and then we'll use the m and the b that's provided in this equation to solve for x, which will be our concentration of our unknown solution. So it should be somewhere in the range of between this data point here and probably just above that data point, between 0.4 and 0.5 is going to be in this range. So our concentration value is going to be anywhere between 0.15 to 0.25 as our concentration. So I'll go ahead and complete those calculations and include them in the video. Hey guys, so I hope you know a little bit more about finding out how to determine the concentration of an unknown solution using a calibration curve and the equation of a line. Looking forward to working more with you in this virtual world. Bye.